Okay, in this video we're going to do the trig section of the chapter 1 review. So question 4 we're going to do down here. So they want you to find the derivative. So let's see what we have. So 4, okay, so I'm going to rewrite it. So I have f of x equals secant squared 3x. Alright, so what I'm noticing is I see my angles not just in x, and I see I have secant squared. So think about that. What is secant squared? So isn't that 1 over cosine squared? So isn't this equivalent to cosine to the negative 2 power? Alright, so I'm going to first think about that. Oh, and I should not have done that. So let's go back here again. So let's rewrite it in terms that we know. So f of x equals cosine to the negative 2, because if I flip it over and then bring it back up, that's what I'm going to get. Okay, so I'm going to write my 3x here. Nice. Alright, so now let's take our derivative. So f prime of x equals. So the first thing you're going to do is do the power rule. So I have negative 2 cosine to the negative, well here, let me back up for a second. So I'm going to erase this because I want to talk about something else first. Alright, so let's write this problem in a safer way. So what is that safer way? The safer way is if you make it cosine 3x, and then you go ahead and put your power out here. Okay, so that's how we're going to start off. Okay, now time to take our derivative. And again, losing my head here. So f prime of x equals negative 2 cosine to the 3x, all raised to the negative 3 power. And then I'm going to tell myself, take the derivative of cosine 3x and take the derivative of 3x. Alright, so the derivative of cosine 3x is what? Cosine is the one that has the negative derivative, so it's going to be negative sine 3x. Don't lose your angle. Then the derivative of 3x is just 3. Okay, so let's see if we can move this to the next page and we'll continue cleaning this up. Okay, so there we have it. Now, that would be a terrible answer. I would never leave my answer in that form. So let's begin the cleanup process. Keep your notation good so that you're not confusing yourself as to what you're doing. Alright, so now I have a negative in front of the sine x, I have a negative in front of the whole term. That means my negatives will cancel. The 2 times the 3 gives me a 6. So this is going to be 6 out here. I have sine 3x, so here's my sine 3x, excuse me, and in the denominator I'm going to have cosine 3x, but that's raised to the 3rd power. Alright, now you can, I guess, leave it like this, but I think you can probably make it a little bit prettier if you play around a little bit. Okay, so I'm not going to write everything, so listen to what I'm saying. I have the 6 that comes along. What is sine over cosine? And you should be saying sine over cosine is tan. So this can be tan 3x. Then what are you left with? You are left with 1 over cosine squared. And isn't 1 over cosine squared just secant squared 3x? So that is a very nice answer. And I would like you to eventually get it down to that point. So make sure you understand how I did that so that you also can do it. And then we'll go on the next page, we'll do question 5. Okay, in this next problem, number 5, I see I'm taking the derivative of a tan squared function. So the first thing I'm going to do is to do some rewriting, and when I rewrite it, it's going to be tan 7x, and then the whole thing is raised to the squared. So now let's take the derivative when it's in that form. So the derivative is going to be, take the power rule, 2 times tan 7x, and this part is raised to the first power. Now take the derivative of tan. Well, why don't I do it this way? I'm going to tell myself to take the derivative of tan 7x and then take the derivative of 7x. So the derivative of tan 7x right here is going to be secant squared 7x. The derivative of 7x will be 7. So now you would never leave your answer in that form, so we're going to clean it up. So 7 times the 2 in the front gives me 14. And then I don't care which order you do this in. Let's say we do it in some standard form. So we'll have the squared term first, and then I'll have the linear term next. Now I don't stand on ceremony for this. You don't have to have one in front of the other, but that's a very nice looking answer. So that's question 5. Question 6 is coming. Okay, here's question 6. Now do not let this form fool you. You don't have to do the power rule, but you do still have to do the chain rule, and you're just going to work from left to right. So here we go. So g prime of x equals the derivative of sine 5x is cosine 5x, and then I'm going to take the derivative of the 5x, which will be 5. So why don't I do this? So I'm going to tell you that I'm going to take the derivative with respect to x of the 5x, and then we'll proceed. Plus, the derivative of cosine 4x will be a negative sine 4x, and then we're going to take the derivative with respect to x of the 4x. Squeeze that in here. Okay, so let's go ahead and clean that up. So my g prime x will equal the derivative of 5x is 5. That is going to go in front. Do not leave it in the back because it's going to be confusing and it's not good form, and it will be marked partially incorrect. So now I have a negative, so I would never have a plus of a negative. So I just have a subtraction then. Once again, bring the constant term of 4, which is the derivative of 4x, in the front. So I have 4 sine 4x, and that's a good answer. So that one's done. Let's do number 7 next. Okay, here's question 7. Again, not a very difficult problem. So when we do question 7, we're going to recognize that we have to do the chain rule. But notice what they're asking us to find. They're asking you to find the second derivative. So we're going to first find the first derivative, clean it up, and then find the second derivative. So let's start by finding the first derivative. So h prime of x will equal, the derivative of cosine is sine, so, and it's going to be negative sine. So negative sine, still the same angle, and then we're going to take the derivative of that angle. Alright, so now let's clean up. So h prime of x equals, the derivative of 6x is 6 from the back, and that's going to come to the front, so I have negative 6, and then I have sine 6x. Alright, so now they've asked us to take the second derivative, so I hope you noticed that it was second derivative was actually the question. So taking this derivative, what I'm going to do is just view the negative 6 as a constant, and the derivative of sine is cosine, so I get negative 6 cosine 6x, and then I'm going to take the derivative once again of the angle. That derivative of the angle is going to be 6. So my final answer will be, in a cleaned up fashion, that 6 comes in front, negative 36 cosine 6x, and that is your best form. So in the next page, we're going to sketch the unit circle. Okay, I'm going to show you the best way to figure out a unit circle. Now, please excuse what this looks like because it's really virtually impossible to draw anything neatly with the stylus. But let's start. So here's my unit circle. Let's get ourselves centered by putting in some of the points. So this is 1, 0. I'm using X's. If I use dots, things go crazy. So this is 0, 1. There's another one here, and that's going to be -1, 0, and then another one down here, and that's going to be 0, 1. So those are your quadrantal angle coordinates. Okay, so now next thing we're going to do, let's go around the circle, and we're going to label all of the coordinates, all of the angles in radians. So to do that, first I'll change my color. So your smallest angle is pi over 6. So we're going to actually go by pi over 6 each time. Okay, this is going to be 0 here. So everything's in radians. Skip the red ones. So I have 1 pi over 6, 2 pi over 6, which reduces to pi over 3. 3 pi over 6, which reduces to pi over 2. 4 pi over 6, which reduces to 2 pi over 3. And then skip. So I did 4. Now I have 5 pi over 6. 6 pi over 6, which reduces to pi. So this is pi. And then I have 7 pi over 6, skip, 8 pi over 6, which reduces to 4 pi over 3, 9 pi, this was 8 pi over 6, 9 pi over 6, which reduces to 3 pi over 2, so that was 9. This is 10 pi over 6, which reduces to 5 pi over 3, skip, so that was 10. This is 11 pi over 6, and then this is 2 pi. Okay, so we have all of our angles that are in sixths. Now you have some quarter angles, so let's do those next, and I'm going to keep the same color. So all the reds are going to go up in the following way. This is pi over 4, so that's 1 pi over 4. The next red is going to be an odd number on the top, 3 pi over 4. The next red is going to be the next odd number on the numerator, so that's 5 pi over 4. And the last one, the next odd number in the sequence, 7 pi over 4. So now I have every single angle I would ever need on the unit circle on the unit circle. So the next thing we need, and this is the last thing we need, are the coordinate pairs. So let's change again, and maybe we'll use green. Okay, so I have this angle, this angle, this angle. I need coordinate pairs for them because those will be my reference angles. So my reference angles coordinate pairs. So what you do is go ahead and write your coordinates. Okay, so I have my parentheses. So here are my parentheses. Actually, do I want to do that? I don't think I have room to do that here. So what I'm going to do is I'm going to count. So you're going to count 1, 2, 3. Then I'm going to count again. 1, 2, 3. Then I'm going to divide everything in half. And then I'm going to take the square root of the numerator. Since the square root of 1 is just 1, I'm not going to even write that. And there you go. Now you have all of your values. You've got your coordinate pairs for all of the reference angles. The last thing I would suggest that you do, and this is just a little helpful thing, if you write CAST, you will hopefully remember that in the first quadrant, all trig functions are positive. In the second quadrant, sine and its partner cosecant are positive. In the third quadrant, tan and its partner cotan are positive. And in the fourth quadrant, cosine and its partner secant are positive. So now you have the entire unit circle. You should be able to create what you need for yourself, and you need to get this correct because I'm going to ask you it on the upcoming test. Okay, in this question, notice they're asking us to take the derivative of a trig function, but then they're asking us also to evaluate an angle, and that angle is not an angle in the unit circle, but don't panic because something nice is going to happen when we take the derivative. So, first off, the derivative is going to be f prime of x equals the derivative of tan is secant squared, so I have secant squared, and this is going to be remaining 7x, and then tell yourself take the derivative of that angle. Okay? The derivative of that angle is just going to be 7. So let me not do that. Hang on. So I'm going to bring the 7 in front, and I have 7 secant squared of 7x. All right. So now the next thing I'm going to do is go ahead and plug in the x that they want me to evaluate, which is pi over 28. Okay, so if they would like the first derivative evaluated at pi over 28, this is how I set that up. I have 7 secant squared, and then I'm going to say 7 times pi over 28. Okay, so pi over 28 is going to reduce to pi over 4. So really what I want to do is take, well, I'm going to clean this up a little bit. So this is going to be, how about if we do this? 7 times, and secant squared is going to really be secant of pi over 4, and I'm going to square that. That's what that means. Notice that the 7 is not inside the square. Okay, so let's think about this. The secant of pi over 4, what is that going to be? So let's go back for a second and look at our unit circle. Okay, pi over 4, I have sine, cosine first, cosine and sine. So I see root 2 over 2 is cosine. And if I want secant, then don't I want to just flip that? So it's 2 over root 2. So let me go back and let's plug that in. So this is going to be 7. This expression is going to be 2 over root 2. And then I'm going to square it. So if you square 2 over root 2, don't you get 4 over 2, which is just 2. And 2 times 7 equals 14, and we're done. So you may want to listen to this again. Notice how I got the secant of pi over 4. I said that's equivalent to 1 over the cosine of pi over 4. The cosine of pi over 4 is root 2 over 2. Flip that over, and you get 2 over root 2, and then I put that in the parentheses and squared it. All right, so that's how you handle 8. Let's go on to number 9. Okay, in question 9, I see I'm taking the derivative of a squared trig term with an angle that's not x, so I'm going to be doing chain. And then once I find the derivative, I'm going to evaluate it at pi over 9. So let's get started by taking the derivative. So g prime of x, well first, why don't I go ahead and rewrite it for you? So let me do that first. So g of x, I can rewrite as sine 3x to the second. Now if you don't need to rewrite this, that's fine, but I'm just doing it for completion. So the first derivative is going to be, power rule, 2 times sine 3x, this whole quantity is taken to the first power. Now I'm going to take the derivative with respect to x of sine 3x, and I'm going to take the derivative with respect to x of 3x. Okay, so what I'm getting when I clean this up, I'm just going to talk this through. Working from the back, the derivative with respect to x of 3x is just 3. 3 times the 2 is 6. That comes in front. The derivative of sine 3x is just cosine 3x. So I'm going to have two trig functions, sine 3x and cosine 3x. Alright, I'm not done because they would like me to evaluate this function at the angle of pi over 9. Now, don't panic, just like last time, nice things will happen when you plug this in. So look what's going to happen. And this is cosine of 3 pi over 9. Because you're going to plug in for x. So the angle that you end up evaluating is not pi over 9, but it is instead, when you reduce, it'll be pi over 3 in both cases. And we can get that from our unit circle. So let's go back, and pi over 3 is your top number here, and these are in coordinate pairs cosine sine. So the cosine is 1/2 and the sine is root 3 over 2. So now I'm going to go back and I'm going to say 6 times the sine value is root 3 over 2, and the cosine value was 1/2. So I have 6 times root 3 over 2 times 1/2. Okay, so let's see what's going to happen. I am thinking that let's take one of these 2's and put it in the 6. So I end up multiplying straight across, and I'm going to get 3 root 3 over 2 for my final answer, and I am done. So that is what g prime of pi over 9 equals. When everything is said and done, you get 3 root 3 over 2. Make sure you can do these problems. This is not a reach for you. This is very doable. Okay, so here is an equation or a question asking us to find the equation of the tangent line drawn to the function at x equals pi over 2. So, first thing I'm going to do is the following. I am going to say that I need to get the equation of a tangent line, so I know that a good way to start is by saying y minus y1 equals m times x minus x1. They've given me the x1, and that is pi over 12. Okay, so this piece is done. Now, I need to get my y1. In order to get my y1, I have to evaluate 6 cosine 2 times pi over 12. All right, that reduces to pi over 6. So y1 is actually 6 times the cosine of pi over 6. All right, so we need a value for cosine of pi over 6. So let's go back to the unit circle. And pi over 6 is our smallest angle. The cosine of pi over 6 is root 3 over 2. So let's plug that in. So this equals 6 times root 3 over 2. The 2 cancels into the 6, and I get 3 root 3. So now what's going to happen is my y1 is going to be 3 root 3. So I'm just going to write that here. And then we're going to copy things over on the next page and start cleaning this up. Alright, so I copied some things over to this page. So far, in my quest to get an equation of a tangent line to the curve, I have gotten the y1 and the x1 was given. Alright, so now I need the slope, and to get the slope I have to take the derivative. So h prime of x is going to be, let's see, 6, and then the derivative of cosine 2x is negative sine 2x. I'm going to put the negative in front here, and this is sine 2x, but then I have to take the derivative with respect to x of the 2x. So this is going to equal negative, and this derivative is 2, so negative 2 times 2 times a negative 6 gives me negative 12, and then I have sine 2x. Now, I need to have the slope of the function, not just the generic slope, the slope of the function at a certain angle, and that certain angle was pi over 12. So this is what I'm looking for. So instead of having my x here, I'm going to erase this x, and in its place, I'm going to put pi over 12. So this is pi over 12. That reduces to pi over 6. That's our small angle again. So let's go back. We need the sine of pi over 6. So I'm going to head back to my unit circle, which is coming in very handy. And the sine of pi over 6 is 1/2. Remember, these coordinate pairs come in alphabetical order, cosine, comma, sine. So I have 1/2 for the value that I want. So let's go back. Okay, so this becomes 1/2. So negative 12 times 1/2 is negative 6. So that's going to be negative 6. So in order to get my final answer without having to go to another page, what I'm going to do is I'm going to erase the m here, and I'm going to plug in its place the actual m value, the slope, which we just found to be a negative 6. So here is my final answer for this problem, number 10. So there you have it. So that ends the trig part of the review for Chapter 2.